Before we begin building our Sentinel environment, here is your lab infrastructure, your Azure free trial. If you don't already have an active subscription, you can create a new Microsoft Azure free trial account, which can give you $200 worth of credits for 30 days. This is more than enough for everything we will be doing in this training, from creating virtual machines to deploying and testing Sentinel. Once your trial account is active, you will have full administrative access to Azure services. This means you can explore freely, deploy resources, and experiment without impacting any production environment. It's your personal cloud sandbox. It's important to keep an eye on your credit balance throughout the training. You can do this directly from Azure portal under the cost management and billing section. Now, a quick tip to help your credit last. Whenever you are not actively using your lab, stop or deallocate your virtual machines. Azure only charges for compute time while a virtual machine is running. So by pausing them, you will stretch your credits significantly. If you happen to reach your credit limit before the 30 days are up, don't worry, you can still convert your account to a pay-as-you-go plan to continue learning. The goal of this setup is simple: give you a risk-free, fully functional Azure environment where you can confidently explore, make mistakes, and learn by doing. So go ahead, activate your trial, verify your $200 credit, and get ready to build your Sentinel lab step by step in the upcoming modules. Welcome everyone to the Microsoft Sentinel end-to-end SOC implementation training. Cover the next few modules, we are going to explore how Microsoft Sentinel helps a Security Operations Center, or SOC, detect, investigate, and respond to cyber threats in real time. Think of this training as a complete SOC workflow, starting from building the environment, onboarding data sources, detecting attacks, and finally automating the response. By the end of this training, you will be able to deploy, monitor, and respond to security incidents using Microsoft Sentinel. We will start in Module 1, where we will set up the foundation, creating a resource group, log analytics workspace, and data collection endpoint. This is where Sentinel gets its data and context. You will also see how RBAC and permissions play a key role in controlling access to your resources. In Module 2, we will prepare our lab systems, a Windows 10 virtual machine, and Ubuntu 22.04 LTS virtual machines, both representing on-premises endpoints. We will configure connectivity and get them ready to start sending logs. Module 3 is where the action starts. We will onboard these virtual machines into Sentinel by installing the Azure Monitor Agent and setting up a data collection rule. Then we will use KQL queries like heartbeat and syslog to confirm that our data is being ingested successfully. Once our data is flowing, in Module 4, we will simulate and detect real-world attack scenarios. We will create analytics rules to identify events like failed RDP logins, suspicious PowerShell activity, SSH brute force attempts, and impossible location logins. You will see how Sentinel transforms raw log data into actionable security incidents. Finally, in Module 5, we will take a step further with automation and playbooks. This is where Sentinel's SOAR capabilities shines. We will create a logic app playbook that automatically responds to incidents. For example, sending an email or Teams notification when specific alert is triggered. By the end of this training, you will have a fully functional Sentinel lab, a solid understanding of detection and automation workflows, and the ability to design end-to-end incident response processes using Microsoft Sentinel. Let's get started with Module 1, Sentinel Environment Setup and begin building the foundation of our SOC in the cloud. Welcome to Module 1, Sentinel Environment Setup. In this module, our goal is to build a solid foundation for our Microsoft Sentinel lab and understand how its architecture is structured. Think of Microsoft Sentinel as the brain of cloud-based security operations center. It collects, analyzes, and responds to security events across your environment. Before we can detect threats or automate response, we first need to prepare the environment properly. That's what this module is all about. The first step is to create a dedicated resource group. Resource groups in Azure are logical containers that help us organize resources and manage access control. By keeping all Sentinel components in a single resource group, we make it easy to manage, secure, and monitor them. Next, we will configure a log analytic workspace or log. This workspace is where all the logs collected from your endpoints, devices, and other services will be stored. Think of it as the central data repository. Everything Sentinel analyzes comes from here. Configuring the log analytic workspace properly ensures that all collected data is available, searchable, and ready for incident detection. After that, we will create a data collection endpoint or DCE. The DCE is essentially the gateway through which logs from agents and sources flow into Sentinel. It allows us to standardize log collection and route it efficiently into the workspace. Once we create it, we will link the DCE with our resource group and log analytic workspace to complete the initial architecture setup. This linking ensures that Sentinel knows where to collect data and how to process it. Another key consideration at this stage is regions, permissions, and RBAC setup. Choosing the right region impacts latency and data residency, while properly configuring role-based access control ensures only authorized users can manage or view Sentinel resources. This is crucial for security and compliance. Finally, we will enable Microsoft Sentinel on the configured log analytic workspace. Enabling Sentinel turns our log analytic workspace into a fully operational SOC platform. At this point, Sentinel can start collecting, analyzing, and eventually generating alerts from the data we feed it. By the end of this module, you will have a fully prepared Sentinel environment ready for onboarding endpoints and collecting security logs. This setup forms the backbone for all the modules that follow, from log ingestion to detection and automation. We will move on to preparing our on-premises virtual machines so that we can start sending logs into Sentinel and validate that our environment is working correctly. Let's go ahead and start with creating our resource group and laying the foundation for our Sentinel lab. All right, everyone, let's start by creating our resource group. We'll go to the Azure portal, click on the resource groups, and we'll click on create. Now think of a resource group as a container, like a folder on your desktop. Everything we build for Microsoft Sentinel will live inside this container. This helps us keep our resources organized and makes management much easier. So since I have only one Azure subscription, I'll choose and leave it as it is. And then I'll name my resource group Sentinel RG Lab. But you can choose a name that makes sense of your own lab environment. A good naming convention is always helpful. For example, including your project environment and region. Something like Sentinel Lab East US could work. This might seem small, but as your environment grows, these details saves a lot of headaches. Next is the region. Think of a region as a physical location of a data center. For example, East US, West Europe, or Southeast Asia. Always try to keep your resources in the same region. Why? Well, if your workspace is in East US, but your endpoints are in West Europe, data has to travel back and forth across regions. This is slower, more expensive, and can increase latency. It's like having your office in one city but your warehouse in another. It just makes operations less efficient. So for this lab, since my subscription is based in East US, I will select East US for my resource group. Now let's go through the creation process step by step. Click Create Resource Group, type your name, select your region, review the settings, and then hit Create. Azure will take a few seconds to deploy this. While that's happening, let's talk about why resource groups are so important. They help you group related resources together, making them easier to manage. You can apply tags and policies at the group level. For example, if you want to track costs for this lab, a tag like Project Sentinel Lab helps. When it's time to clean up, you can delete this entire resource group and everything inside will be removed. This is much safer than deleting individual resources one by one. And that's it. Your resource group is ready. Every new resource we create from now on, like virtual machines, log analytics workspace, or storage accounts, will go inside this group. Here is a quick analogy for regions. Imagine your Azure region as a physical data center. If your workspace is in East US, but your endpoint is in West Europe, data has to travel across continents. That can slow things down and cost more. Keeping everything local is like keeping your office and warehouse in the same city. Everything works faster and more efficiently. Before we move on, take a moment to review your resource groups. Notice the location, name, and subscription. These details will affect all the resources we deploy later. All right, now that we have our resource group ready, let's create the log analytics workspace, or LAW for short. This workspace is where all our logs and telemetry data will be stored. Think of it as the central database for Sentinel. Every security events such as failed login attempts, unusual network activity, alerts from other systems will flow into this workspace. Without it, Sentinel has nowhere to store or analyze the data. Let's go step by step. In the Azure portal, search for Log Analytics workspace. Click on it and then click on Create. Make sure you select the same subscription and resource group that we have created earlier. In this case, Sentinel RG Lab. This keeps everything organized in one place. Now for the naming convention, I will name this workspace Sentinel Law. Naming is important because later we have multiple workspaces or multiple labs. Clear names help avoid confusion. You might include the environment, project, or region in your naming, like Sentinel-Law-East US. Next, choose the same region as your resource group. Why is this so important? Well, data latency and cost increase when your resources are spread across regions. If your resource group is in East US and your workspace is in West Europe, every log event has to travel across continents, which makes slower and more expensive. Keeping them together is like keeping your office and warehouse in the same city, and that everything works faster. Once all fields are filled, click on Review plus Create, and then Create. Azure will deploy the workspace. This usually takes a few seconds, so we have a moment to discuss some best practices. The first one is retention policies. By default, logs are retained for 30 days. Depending on your requirements, you can adjust this. Longer retention is useful for forensic investigations but can increase cost. The next one is tags. Apply tags like project colon sentinel or environment colon lab. Tags help with cost management and tracking resources. And the third one is access control. Make sure only authorized users can access the workspace. You don't want sensitive logs open to everyone. Once deployed, click on the workspace name. You will see the overview blade with options for logs, agents, and settings. This is where you will manage everything for the workspace. You can install agents to collect data from virtual machines or other sources, configure alerts, and review metrics. Here is a quick analogy. If Sentinel is the security brain, then the log analytics workspace is the memory bank. Everything Sentinel knows, such as failed logins, network activity, suspicious alert, is stored here. Without it, Sentinel is like a brain without memory. It can think, but it has no data to act on. Before we move on, take a moment to explore the overview blade. Notice how the tabs are structured. Logs is where you will query your data. Agents is where you install data collectors, and setting is where policies and retentions are managed. Understanding this structure now will save a lot of time later. Finally, remember that every resource we create in Sentinel will link back to the workspace. It's the foundation for alerts, detections, hunting queries, and incident investigations. Keep it organized, consistently named, and regionally aligned. This workspace will be the heart of your Sentinel lab. Now that we have our log analytic workspace ready, the next step is to create a data collection endpoint or DCE. A data collection endpoint is a secure entry point for all data coming into our environment. Think of it as the front door of a building that anything that wants to enter our environment must come through this door. It ensures that all incoming data is authenticated, secure, and routed correctly. Let's go through the steps together. In the Azure portal, search for data collection endpoints. Click on it, then click on Create. Now, make sure you select the resource group we created earlier, Sentinel RG Lab. Keeping all resources in the same group makes management much easier and helps avoid confusion later. Now, let's choose a name. I will name mine Sentinel-DCE. Naming conventions are important because in large environments, you might have multiple endpoints. A clear name helps everyone know what this endpoint is for. Next, select the same region as your resource group and Log Analytics workspace. Why? Because keeping resources in the same region improves performance and reduces latency, just like having your mail room close to your warehouse. Once everything is filled out, click Review plus Create and then Create. Azure will deploy the DCE in a few seconds. When it's deployed, click on the data collection endpoint to open it. Under the Overview tab, copy the logs ingestion URL. This acts as our endpoint for the Azure Monitor Agent. It tells the agent where to send collected data, ensuring logs flow into our workspace correctly. Here is a quick analogy. If you think of the Log Analytics workspace as your storage room, the data collection endpoint is the front gate where all deliveries arrives. Every machine, virtual machine, or data source that sends the logs will first drop them here. The data collection endpoints ensures that all data is received securely and sent to the right place. Some additional best practices. Keep your endpoint secure. Only authorized agents should use it. Naming clarity is important for labs versus production environments. For example, adding lab or prod at the end of the name helps differentiate endpoints. Later, when setting up data collection rules, we will reference this endpoint to tell specific agents where to send their logs. Before moving on, take a moment to explore the DCE blade. Notice the overview, configuration, and access control tabs. Understanding where settings live will make it easier when we start connecting machines and setting rules. To summarize, the data collection endpoint is like the front door for all incoming data. It secures, authenticates, and routes logs to our workspace. With it in place, we can now safely start connecting data sources and building our monitoring environment. Now that our log analytics workspace is ready, let's enable Microsoft Sentinel on it. This is the critical step that transforms a simple workspace into a security engine capable of collecting, analyzing, and alerting on threats. So go to the search bar at the top and write Microsoft Sentinel. Select it and then click on Create. Here we can see our log analytic workspace we created earlier, which is Sentinel Law. Click on it, select it, and then click on Add to enable it. You will see this button is how we enable the Sentinel service for this workspace. At this point, Azure begins provisioning the Sentinel environment. This may take few moments. While waiting, let's understand what's happening behind the scene. Sentinel is deploying its analytics engine on your workspace. It's preparing dashboards, creating default data connectors, and setting up storage for incoming logs. Without enabling it, all the logs you collect through agents or connectors will not be processed for threads. Here's a quick tip. During deployment, take a look at the Overview tab. Notice how the page refreshes as Sentinel initializes. You will see sections like data connectors, incidents, and analytics become active once provision complete. Once Microsoft Sentinel is enabled, click on the Sentinel workspace names. You will land on the main Sentinel dashboard, which includes tabs like Incidents, Automation, Data, and Analytics. This new layout focuses on the SOC workflow. Incidents, where alerts are grouped for investigations. Analytics, where detection rules are managed. Data, to connect or manage your data sources. And automation, to define playbooks and automated responses. If you would like to see data flow or workspace health metrics, you can explore workbooks for visual dashboards, logs for raw data, and event queries. Think of enabling Sentinel as turning on the central nervous system of your security environment. The workspace is the body, the logs are sensory signals, and Sentinel interprets those signals to detect threats. By the end of this step, your workspace is no longer passive, it is actively listening, analyzing, and preparing for incident detection. Take a few minutes to explore each section, click on tabs, and get familiar. The more comfortable you are with the interface now, the easier it will be when we add connectors and alert rules in the next steps. All right, now that we have successfully linked our workspace and endpoint, it's time to discuss something just as important: permissions and access control. This is an area that's often overlooked when people set up Microsoft Sentinel Labs, but it's absolutely critical for real world environments. If permissions are not configured correctly, you could face errors during setup, or worse, leave your environment exposed to unauthorized changes. So let's break this down. Azure uses a system called RBAC, role-based access, To manage who can access what and where, think of RBAC as Azure's security gatekeeping system. Every resource, whether it's a resource group, a log analytic workspace, or Sentinel itself, is protected by this system. RBAC operates on three key components. The first one, security principle, the who. This represents the entity requesting access. It could be a user like you or a team member, a group, for example, the SOC analyst group, or a managed identity used by Azure services or automation scripts. Second, role definition, the what. This defines what the principal can actually do. Azure provides built-in roles like reader, can view resources but cannot make changes. Contributor can create and modify resources but cannot assign roles. Owner has full control, including the ability to assign roles. Third, scope, the where. This determines where the permissions apply. It could be at the subscription level, granting access to everything under the subscription, or the resource group level, which limits access to all resources in that specific group, or even a single resource, like a specific log analytics workspace or virtual machines. Let's take a moment to visualize this. Imagine you are managing a large office building. The security principal is the person holding the key card. The role definition determines what the key card can do, maybe open doors, maybe access certain floors. And the scope defines which part of the building those permissions apply to. For our Sentinel lab setup, we need a few specific permissions to make everything work smoothly. At a minimum, you will need owner or contributor access at the resource group level. This ensures you can create and manage all the components we have been working on, your resource group, log analytics workspace, data collection endpoint, and Sentinel itself. For users who only need to view or query data, we can assign reader or log analytics reader roles. These roles allow them to see logs, run queries, and view dashboards, but not make any configuration changes. Now let's check the permissions together in the now let's check the permission together in the portal. Open your resource group. Our is called Sentinel RG Lab. On the left-hand menu, click Access Control IM. Here you will see a list of everyone who has access to this resource group and the roles they have been assigned. If you're working in a shared lab or team setting, click Add and add role assignment. A panel will appear showing available roles. Here are a few examples you will commonly use, like log analytics, contributor. This allows managing and editing workspace configuration. Or we can search monitor reader. This can view monitoring data but cannot modify anything. Select the role you want to assign and click Next. And then choose the user group or service principal. Select members. You can search for the user here. I have only one in my subscription. I'll choose that. Select it. And you can review plus assign. And that's it. You have just applied RBAC permissions to your resource group. Here is a quick analogy. Think of RBAC like an office security system. The owner has the master key to every door. The contributor can enter most rooms but cannot rewire the building. And the reader can only look around. They can see what's happening but cannot touch anything. Now let's connect the dots between regions and permissions because they work hands in hands in Azure Sentinel. We have already seen how keeping everything in the same region, the resource group, log analytic workspace, and data collection endpoints ensures smooth connectivity. But there is also a security and compliance angle here. Data cannot flow between regions unless you specifically configure it to. This is not just a technical limitation, it's also a security safeguard. Keeping everything local improves performance and reduces compliance risk. For example, if your organization operates in Canada, but your logs are stored in East US, that might breach data residency laws or organizational policies. So always double check your regional settings, especially in regulated industries like finance or healthcare. On the permission sides, one of the most important rules in cybersecurity and Azure RBAC is the principle of least privilege. This means gives users only the permissions they absolutely need to do their job, nothing more. Too many users with full access like owner or contributor roles increases the risk of accidental misconfigurations or malicious changes. By limiting access, you minimize the blast radius if something goes wrong. Here is a real world example. In many security incidents, it was not an external hacker but an insider or a misconfigured permission that caused data exposure. RBAC helps prevent that by enforcing accountability and control. Before we move on to the next module, let's quickly recap what we accomplished in Module 1. First, we created a dedicated resource group, which will serve as the container for all our Sentinel resources. This ensures our lab is well organized and manageable. Next, we configure the log analytic workspace. This is where all our log data will be stored and analyzed. Think of it as the central hub for all telemetry from our endpoints and devices. We also set up the data collection endpoint, which links our endpoints to the workspace and ensures that log flow correctly into Sentinel. Importantly, we reviewed regions, permissions, and RBAC roles to make sure only authorized users can manage and access these resources, which is crucial for both security and compliance. Finally, we enable Microsoft Sentinel on our workspace. At this point, our environment is fully operational and ready for the next step, onboarding endpoints and validating log ingestion. With this foundation in place, we are now ready to move to Module 2, where we will prepare our on-premise virtual machines to start sending data into Sentinel. This is the next step in building our complete SOC workflow. Welcome to Module 2, Preparing our on-prem virtual machines. In this module, our goal is to deploy and prepare virtual machines that will act as an on-premises endpoints for monitoring within our Microsoft Sentinel lab. Think of these virtual machines as the sensors in your SOC environment. They generate the telemetry that Sentinel collects and analyzes. Properly preparing these machines is essential because any misconfiguration could prevent logs from being ingested or even affect the accuracy of detection rules later on. First, we will deploy two virtual machines, a Windows 10 virtual machine representing a typical on-premises workstation in an enterprise environment, and Ubuntu representing a Linux server or endpoint. Deploying these two operating systems allows us to simulate a realistic enterprise environment where both Windows and Linux systems exist, and we can monitor events across both platforms. After deployment, the next critical step is configuring networking and connectivity. Both virtual machines must have internet access so they can communicate with your services, download updates, and send logs. For Windows, we ensure RDP is enabled so we can access the system for configuration, and for Ubuntu, we ensure SSH connectivity. Proper network configuration is also important for agent installation, which we will do it in the next module. Once networking is set, we will install all required updates and security patches. Keeping virtual machines up to date is a security best practices and ensures compatibility with Azure Monitor Agents and other telemetry components. This step also mirrors real-world enterprise environments where endpoints are expected to remain patched and secure. Finally, we will prepare the virtual machine for agent installation and log forwarding. This includes ensuring that any firewall or endpoint protection settings allow the Azure Monitor Agent to communicate with the data collection endpoint and log analytics workspace. It also means verifying that the system time, host name, and other configuration details are correct, as these can impact log collection accuracy. By the end of this module, both virtual machines will be fully deployed, configured, and ready to onboard into Microsoft Sentinel. These machines will serve as the data sources for our lab, allowing us to simulate real-world monitoring, detection, and response scenarios. In the next module, we will move into Module 3, Onboarding and Log Validation, where we will install the Azure Monitor Agent on these virtual machines, configure data collection rules, and confirm that logs are flowing successfully into Sentinel. Let's go ahead and start with deploying our Windows 10 virtual machine first, followed by the Ubuntu 22.04 LTS virtual machine, and prepare them for connectivity and telemetry collection. All right, let's deploy our on-prem Windows 10 virtual machine in VMware. I'll walk you through each click, and I will call out a couple of examples and quick checks so you will not get stuck. Before we start, you will need the Windows 10 ISO. You need to go to the official Microsoft Evaluation Center, download the Windows 10 Enterprise Evaluation ISO, and save it on your machine. We will use it in just a moment. I'll drop the link in the resource folder. First, open VMware Workstation. Click Create a new virtual machine and choose Typical Recommended and click Next. And then choose I will install the operating system later and click Next. Choose the guest operating system name, Microsoft Windows, and make sure version Windows 10 and later is selected. Click Next. Here you name the virtual machine Windows 10 Lab 01. So it's obvious later which machine it is. Pick a location on disk that has at least 80 GB free. We don't want to run out of space while installing updates or agents. Here you need to choose the maximum disk size. I'll leave it as 60 GB and make sure the second option split virtual disk into multiple files is selected. Click Next. Then we will click on Customize Hardware. For CPU and memory, allocate 2 CPUs and 2 number of cores per processors. And I'll allocate 8 GB of RAM. That's a good balance for lab performance without using too many local resources. Example, if your laptop is low on RAM, reduce to 2 GB temporarily, but expect slower performance. And then go to network adapter. Important networking note here. Set the network adapter to bridge. Disconnect your VM directly to the same network as your host and other lab systems. It's ideal for testing scenarios where machine needs to communicate directly with each other. If you're working on a laptop or want the virtual machine to share your host internet connection without exposing it to the local network, you can choose NAT instead. Example, in my lab, I use bridge mode so my on-prem Windows 10 virtual machine can communicate directly with other lab machines and the management server. Click Close and then click Finish. And the next step is you have to go back to Edit Virtual Machine Settings, go to CD DVD SATA, and choose your ISO image. So go to Browse, Desktop, and this is my ISO image. Once you have selected your ISO, click OK and click on Power on this virtual machine. The Windows installer will boot from the ISO. Walk through the normal setup screens, select your language, keyboard, and click Install Now. When prompted, choose the correct edition and accept license terms. I'm not going to go and follow all the steps as I have already set up my Windows 10 machine. So I'll go to my virtual machine Windows 10 Lab 01 and I'll power on this virtual machine. I have created a user with the lab admin name and I'll log in with my password. Before doing anything else, let's install VMware tools. This improves mouse performance, screen resolution, and enables copy paste between host and virtual machine. In VMware Workstation, go to the top menu and select VM. Here you will see Install VMware Tools. Mine one is showing Reinstall VMware Tools because I have already installed VMware tool. Once you install, you will get a pop-up says that DVD VMware Tools. Select to choose what happens with this disk. This mounts the tool ISO inside the virtual machine's virtual CD drive. I'll open with Open Folder to view files. And we have to click on Setup to run the VMware tools. Click Yes. You will get a visit for VMware tool setup. Click Next, choose Typical and click Next, and then install. Once the installation is complete, click Finish and reboot the virtual machine when prompted. I'll click on Finish and we'll restart our virtual machine. I'll log in with my account. Now, after installation, Windows will go through first time setup and then brings you to the desktop. Before installing anything else, let's confirm basic connectivity. So click on Search and type CMD. As run as administrator, click Yes and run ping google.com. Wait for reply. You should see reply from 8.8.8 or similar. If you get request timeout, stop and check the virtual machine's network setting. Ensure the adapter is connected and the host machine has internet. Next quick check. Enable remote desktop so you can connect later for demos. Open setting, click on system, click on remote desktop, and toggle enable remote desktop. Click on confirm and confirm again. Note the PC name shown here. We will use it if we RDP later. Also, open Windows Defender Firewall and ensure RDP is allowed on the private profile. So click on Allow an app or feature through Windows Defender Firewall and confirm Remote Desktop is enabled. The wizard does this automatically when you enable Remote Desktop, but it's worth verifying. If you're using NAT and cannot RDP from your host, use VMware's console to connect instead. Finally, create one test event to validate later when we connect the agent. Open an elevated command prompt and run. Run this command. This writes a custom event to the application log that we will query from Sentinel after the agent is installed. Alright, your Windows 10 VM is created, networked, reachable, and has a test event. If anything failed, check the network adapter type, NAT versus bridge. Reboot the VM and rerun the ping test. With everything looks good, move on to the agent installation step. Now that our Windows 10 virtual machine is up and running, let's create our Linux endpoint. This will be our on-prem Ubuntu server running Ubuntu 22.04 LTS. Just like before, open VMware Workstation and click Create a new virtual machine. Choose Typical Recommended and click Next. Here, I will choose I will install the operating system later and click Next. Select the Linux option and make sure the version it says Ubuntu. All right, and then we will click on Next. Here you can name the virtual machine. I will call Ubuntu 22.04 LTS and click Next. And I will choose our maximum disk size. I'll make it 40. And make sure the second option, split virtual disk into multiple file, is selected and click Next. Then we will click on Customize Hardware. I will go into the processors and allocate 2 CPUs and 2 number of cores per processors. And then I'll choose the RAM, 6 GB. Linux is lighter than Windows, so it runs perfectly fine with these resources. If you have got more power on your machine, bump it to 8 GB RAM. It will make package installations a bit smoother. For networking, I'll choose it as bridged. Again, select either NAT or bridge, whichever you used for the Windows VM. If you use NAT for Windows 10, keep NAT here too. This way both machines are on the same subnet and can communicate later when we test across platform logging. We chose bridge for Windows, choose the same for Ubuntu. And then click on close and hit finish. Now, when the wizard asks you for the installation media, select the Ubuntu 22.04 LTS ISO you downloaded earlier. If you don't have one, you can grab it from the official website. You can get the link from the resource folder. And here you can click on 64-bit PC and install your ISO. I will not continue because I have already downloaded it. I'll go back to my VM workstation. I'll click on Edit and choose the CD DVD and use ISO image file, which we have downloaded. You can go click Browse and choose your ISO image. Hit click and then click on Power on this virtual machine. The Ubuntu installer will boot from the ISO. Now walk through the standard setup screens. Again, I will not go through all these steps because I have already installed my Ubuntu virtual machine. But here is the quick step. Choose English as the language. Select Install Ubuntu. For keyboard layout, use English US or your local layout. And when it asks about the updates and software, choose normal installation and check install third-party software for graphics and Wi-Fi hardware. That ensures all drivers are included. When prompted for storage during the installation, select Erase Disk and install Ubuntu. Don't worry, this only affects the virtual machine's virtual disk. And then click Continue and the installation will start. It usually takes 3 to 5 minutes depending on your host performance. I will power on this virtual machine. I name a user lab user and I will enter my password. Let's talk about why we adding a Linux machine. Example, in a real world environment, Linux often runs web servers, application servers, or even security appliances. Collecting logs from Linux gives you visibility into SSH logins, privilege escalations, and syslog messages, all crucial for detecting suspicious activity. Once logged in, open a terminal by right click and open in terminal and test your internet connectivity by typing ping c4 google.com. If you see replies like 64 bytes from, you are online and ready to go. If you get an error like temporary failure in name resolution, check your network adapter settings. Make sure it's still NAT or bridged and the virtual machine is powered on after host reboot. Before we proceed further, you need to make sure your Ubuntu system is fully updated. This ensures that you have latest security patches, bug fixes, and updated software packages, which keeps your system stable and secure. Let's start by typing the following command: sudo apt update and hit enter, and then enter your password. Enter. Now this command does not actually install updates, it just refreshes the package list from Ubuntu's repositories. In simple terms, it tells your system, hey, what new software versions are available out there? Next, we will install all available updates with this command: sudo apt upgrade y. Here, upgrade downloads and install the latest version of your currently installed packages. The -y flag automatically answer yes to all prompts. And that's it. You have successfully updated and upgraded your Ubuntu system. Keeping your system up to date ensures better performance and security, a habit every Linux user should have. Finally, let's generate a quick test log entry we can use later. Type logger Sentinel Lab Ubuntu test event and hit enter. This adds a message to the system's location, this, which will query from Sentinel once the Azure Monitor Agent is installed. That's it. You now have two fully functional on-prem virtual machines, one Windows and one Ubuntu, both with internet connectivity and each generating test events that we will soon forward into Microsoft Sentinel. Take a quick moment to Snapchat both virtual machines before moving on. This gives you a restore point if anything goes wrong during the agent installation in the next step. At this point, think of what we have built. Your VMware environment is now acting like a corporate branch office, while Microsoft Sentinel is sitting in the cloud. These two machines, your Windows 10 endpoint and your Ubuntu server, will be your data producers. They will send heartbeat, security, and syslog data up to Sentinel, allowing you to visualize on-prem activities side by side with cloud telemetry. Before we move on to Module 3, let's quickly review that we accomplished in Module 2. First, we successfully deployed our two virtual machines, a Windows 10 and Ubuntu, which will act as our on-premises endpoints for monitoring. These represent a realistic enterprise environment with both Windows and Linux system. Next, we configure networking and connectivity. For Windows, RDP access was enabled, and for Ubuntu, SSH connectivity was set up. This ensures that both virtual machines can communicate with your services and are ready for agent installation. We also installed all required updates and security patches, which is critical for security, compatibility, and ensuring accurate log collection. Finally, we prepared both VMs for agent installation and log forwarding, verifying that they are ready to send telemetry data into our Sentinel lab. With these virtual machines properly configured, we are now fully ready to move to Module 3, Onboarding and Log Validation, where we will connect these endpoints to Microsoft Sentinel, install the Azure Monitor Agent, and confirm that logs are being ingested correctly. Great work. Let's proceed to the next module and start onboarding our endpoints into Sentinel. Welcome to Module 3, Onboarding and Log Validation. This module, our object is to connect the virtual machines we prepared in Module 2 to Microsoft Sentinel and ensure the logs are being ingested successfully. Think of this as turning on the data pipeline between our endpoints and Sentinel. Without proper onboarding, Sentinel will not be able to analyze the activity happening on these systems. The first step is to install the Azure Monitor Agent or AMA on both our Windows 10 and Ubuntu. The AMA is the key component that collects telemetry from our endpoints, including system events, logs, and performance metrics, and forwards it to Azure. It's lightweight, efficient, and optimized for cloud monitoring. Once the agents are installed, the next step is to create and configure data collection rule or DCR. The data collection rule tells the agent exactly which data to collect and where to send it. It maps the logs from our endpoints to the correct workspace in Azure Log Analytics and ensure that we only collect relevant information. Proper DCR configuration is crucial for accurate and efficient monitoring. After creating the DCR, we will link both VMs to the DCR and data collection endpoint. This establishes the connection between our on-premises endpoints and Sentinel, enabling telemetry to flow into the log analytics workspace. This is a critical step because without this linkage, the data collected by the agents would have nowhere to go. With the connection established, it's time to validate that logs are flowing correctly. We will start by using KQL queries in log analytics. For example, we can run heartbeat and syslog. The heartbeat query shows us that our endpoints are actively reporting to Sentinel. The syslog query, especially for our Ubuntu virtual machine, confirms that Linux system logs are being ingested properly. We will also visually verify that this data appears in the heartbeat and syslog tables within the Sentinel workspace. This step ensures that our environment is ready for detection and alerting in the upcoming modules. By the end of this module, both Windows and Linux virtual machines will be fully onboarded into Sentinel, sending telemetry data continuously. This sets the stage for Module 4, where we will create analytics rules to detect real-world attack scenarios and generate incidents. Let's start by installing the Azure Monitor Agent on the Windows virtual machine, and then we will proceed with the Linux virtual machine installation. Once both agents are running, we can move on to configuring the data collection rule and verifying that logs are successfully ingested into Sentinel. In the previous sections, we built our Sentinel environment and enabled data collection. Now it's time to bring in on-premises machines, a Windows 10 and Ubuntu virtual machine, to feed real endpoint logs into Sentinel. Think of these virtual machines as your corporate workstations and servers sitting inside your network. By adding on-prem machines, we will get a full picture of what's happening across your environment. To do this, we will use Azure Arc. Azure Arc lets your on-prem machines become Azure aware without moving them into the cloud. Once a VM is Arc enabled, we can generate a Sentinel onboarding script directly from Azure. Running this script will install the Azure Monitor Agent on the virtual machine, link the agent to our data collection rule and data collection endpoint, and start sending logs from machines into Sentinel automatically. Imagine it like adding sensors to your physical machines. The Windows 10 will report event logs and system telemetry, while the Ubuntu will send syslog and authentication events. This gives you a real-time hybrid security view. Example, in my lab, after onboarding a Windows 10 virtual machine, I could immediately see heartbeat logs in Sentinel. When I onboarded Ubuntu, syslog entries appeared within minutes. This shows the Sentinel is now actively monitoring both cloud and on-prem endpoints. By the end of this module, both virtual machines will be connected, sending live logs, and ready for us to create alert rules, analytics, and incident investigations in the next module. So grab your on-prem virtual machines and Azure portal. Let's start connecting your environment to Sentinel. Now we will onboard our Windows 10 on-premises virtual machine. In an enterprise, this would typically represent a user workstation or a small server in your corporate network. By connecting it to the Azure Sentinel, we can monitor its activity in real time. So let's register our Windows 10 virtual machine with Azure Arc. First, navigate to the Azure portal and click on Azure Arc. If you cannot find Azure Arc here, you can search it here in the search bar. Click on it and click on Machines on your left-hand side. And then click on Add or Create. And we will go with the Add a Machine option. We are going to add a single server, so click Generate Script. Here we will choose our settings for Windows 10 Virtual Machine to generate onboarding script. We'll choose our subscription and we will choose our resource group, which is Sentinel Resource Group Lab. We'll choose our region. In this case, we have region in East US. We need this onboarding script for Windows. So select Windows from the drop-down and leave the rest of the setting as it is. Click Next. Next. And here you can click on Download to download the script. You will get a warning. I'll click Keep to keep the file. Now we need to move this script to our Windows 10 virtual machine. In this case, I'll simply copy this file. We'll go to our Windows 10 virtual machine, right click and paste. Now, if you're unable to copy and paste in your virtual machine, you need to go to virtual machines and click settings, go to options and click on guest isolation. Make sure under the guest isolation, these two options are enabled, which is enable drag and drop and enable copy and paste. Now we will open a Windows PowerShell and run as administrator. Click yes. Now we have our onboarding script on desktop. We need to run this script. So we need to go to users, lab users, and go to desktop. And here we can see we have our script available. All you need to do is to go and run this script. and hit enter. Now if you get this error, don't worry, we will fix it. So this error means that file cannot be loaded because running scripts is disabled on this system. This error happens because Windows PowerShell has something called an execution policy, which controls whether scripts are allowed to run or not. By default, it's set to restricted, meaning you cannot run any .ps1 script files. So let's check what your current policy is. So make sure your PowerShell is open as an administrator writes. Type get execution policy and hit enter. And if you see restricted, that's why your script failed. The safest way to fix this to temporarily bypass the restriction, just for this session, run this command. This means PowerShell will allow scripts to run only in this window. Once you close it, everything goes back to normal. But if you want to allow script to run permanently for your user account, especially useful in a lab setup, you can use this command instead. The remote sign policy is safer. It allows local script to run, but still blocks unsigned script downloaded from the internet. So hit enter. And press Y to accept and hit enter. And that's it. You have fixed the running script is disable error in PowerShell. Now let's go back and run our onboarding script again. Hit enter. As you can see, it is installing. Now the script does three critical things automatically. Install the Azure Monitor Agent. This is what collects logs, events, and telemetry from the machine. Second, it links the agent to your DCR and DCE. No manual configuration is needed. The pipeline from virtual machine to Sentinel is automatically established. Third, start sending logs to Sentinel. Within minutes, you will see heartbeat and telemetry data flowing. Now it will ask you to connect to your Azure portal. I'll enter my email address of Azure portal and click next. And I'll go to my Authenticator app and approve the request. It says authentication complete. You can return to the application and feel free to close this browser tab. Let's close it. As you can see, it is successfully connected machine to Azure. Great. Next, we have to create a data collection rule. So what is a data collection rule? Data collection rule or DCR is a set of instructions that tells Azure what kind of data to collect, from where, and where to send it, usually to a log analytics workspace. Think of it like a bridge between endpoint and Sentinel. It decides which logs or metrics get forwarded for monitoring and analysis. And why do we need a DCR? We need a DCR because without it, your virtual machine or on-prem systems will not know which data to send to the cloud. When you install the Azure Monitor Agent, it relies on the DCR to understand what to collect. For example, security events, system logs, or performance metrics. In short, no DCR is equal to no data flow into Sentinel. And how it fits in the workflow? First, you install the Azure Monitor Agent on your endpoint. Second, the DCR define what logs to collect. Third, data is to send your log analytic workspace where Microsoft Sentinel can analyze it. So remember, the DCR is the rulebook that connects your machine to Sentinel. Without it, Sentinel has no visibility into what's happening on your systems. So let's go to our Azure portal and in the search bar, look for data collection rules or DCR. Then click on data collection rules and click on create. We will create a rule name and choose your Azure subscription and choose your resource group. In this case, our resource group is Sentinel RG Lab. So platform is Windows, and we have to choose our data collection, which is Sentinel DCE we have created earlier. And then click on resource, click on add resource. So this is our resource group we are working on. Open it. And we can see our Windows 10 virtual machine here. Select and apply. Click Next, Collect and Deliver. Click on Add Data Source and choose the data source type. We'll go for Windows Event Logs. Now here on this page, you need to check what kind of logs you would like to collect from Windows. In this case, I'll choose all. Next, click on Destination, add a destination, Azure Monitor Logs, select your subscription, and here you need to choose your log analytic workspace as a destination, which is Sentinel Law. And then click on Add Data Source. Once you're done, click on Review plus Create. Verify your settings and click Create. As you can see, Azure is provisioning the DCR and it successfully created the data collection rules. Now, as you can see that our DCR is listed here. All right, now that our workspace is connected and our agent is reporting data, let's head over to Microsoft Sentinel and run our first KQL query to make sure everything is working. Let's go to Microsoft Sentinel. And from the Sentinel portal, select your workspace. Then on the left-hand menu, click on Logs. Close this window. And on this new query tab, make sure you select KQL mode from the simple mode. This is where we will use our KQL to interact with our data. Now in the query editor, type the following command. The heartbeat table contains data from the Azure Monitor Agent. Each record shows that the agent is alive and successfully sending data to our workspace. If you see results here, great. That means your endpoint is connected and communicating with Sentinel correctly. You can even expand a row to see details like the computer name, operating system type, and time-generated fields. And that's it. You have just run your first KQL query in Microsoft Sentinel. That heartbeat table is the perfect way to confirm that your data collection is working before diving into deeper security analytics. Next, we will onboard our Ubuntu on-premises virtual machine. Think of this as a Linux server in your corporate network. By connecting it to Azure Sentinel, we can monitor syslog events, authentication logs, and system telemetry in real life. Now let's go back to our Azure portal and click on Azure Arc. Click on Machine on the left-hand side, and then hit Add and Create. Again, we will add a machine and add a single server only. Generate script. Here we make sure that our right subscription is selected and also choose the resource group. Region East US. This time we'll choose Linux and leave rest of the settings as default. Click Next, Next, and download the onboarding script for Linux. Now I will copy this script and will move it to Ubuntu Virtual Machine. Go back to Ubuntu Virtual Machine, right click on Desktop and click on Paste. We have successfully moved our onboarding script to virtual machine. And again, if you cannot copy and paste, make sure go into the VM settings, go to options and click on guest isolation, and under the guest isolation make sure these two options are enabled. Enable drag and drop and enable copy and paste. Now we will open our terminal. Now let's first do the execution mode of our onboarding script file. As we can see, we have our onboarding script here. Chmod X onboarding. Once done, now let's go and run our onboarding script. Type the name and hit enter. Now let's go and run our onboarding script. We have the onboarding script on desktop. So let's go to desktop and type the file name and hit enter. Now, as you can see that it is asking to go to the browser and open the Microsoft.com device login page and enter this code. So let's go to our Firefox. Let's grab this code and paste it here. Click next. Now let's type the same email we have entered when we were connecting the Windows 10 virtual machine. So I'm going to put the Azure portal email address. Click next and send notification. I need to go to my Authenticator app and approve this request. All right, yeah, click on continue. And it says that you have signed into the Azure Connected Machine agent application on your device. You may now close this window. And as we have the confirmation here, it says that machine already connected. Great. Next, we need to configure the data collection rule or DCR for our Ubuntu virtual machine, just like we did earlier for the Windows 10 machine. Remember, the DCR acts as the bridge between your virtual machine and Azure Sentinel. In simple terms, it defines what data to collect, how to collect, and where to send it. When we connect any system to Azure Monitor or Microsoft Sentinel, we use a DCR to tell Azure, collect logs and metrics from this machine and send them to this log analytic workspace. Think of it like a data pipeline configuration between your Ubuntu machine and Azure. And remember, no DCR means no data flow into Sentinel. Without it, Sentinel will not receive any logs, metrics, or heartbeats from your Ubuntu system. All right, let's head over to the Azure portal and configure the DCR for Ubuntu step by step. In the Azure portal, go into the search bar and type DCR and click on Data Collection Rules and click Create to add a new rule. Here we will name it DCR Sentinel Ubuntu Lab. Choose the right subscription and then choose the resource group. We'll leave the region East US and platform this time Linux. Data collection endpoints, choose your DCE, which we configured earlier, Sentinel DCE, and click on Next Resources. Add a resource, open your resource group. As you can see, we have our Ubuntu virtual machine listed here. Select and apply. All right, so we have added a resource. Next, collect and deliver. Add a data source. Now for the Linux, we need to go and choose Linux syslogs. Let's discuss what exactly is syslog. Syslog is the standard logging system used by Linux. It records events from the operating systems, applications, and services. Basically, everything that happens on your machine. Think of it just like the event viewer, where you have different logs, categories such as application, system, security, and setup. Remember when we configured the DCR for Windows? We selected event logs such as security, system, and application. Those categories allowed us to collect Windows Event Viewer logs and send them to Microsoft Sentinel. For Linux, the concept is exactly the same, but instead of event logs, we work with the syslog facilities. Syslog is the Linux equivalent of the Event Viewer. It's the system-wide logging service that records activities from the operating system, services, and applications. For this lab, here is what we are going to select. We're going to select log auth. That means to capture login attempts and sudo actions with a minimum log level log info. Next, we will select auth priv. This is for privileged authentication logs such as SSH or root access. And I'll choose the same for the log info. And we'll go for log daemon. This is to track system services activity. And I will choose log notice. And we will go for, and then we go for log syslog. This is to record system-wide events. And I'll choose log information as a minimum log level. Next, I will also choose kernel. This is to detect kernel or operating system level issues. And I will go with a log warning. And let's select cron. Cron is to monitor scheduled task. And this is, I will choose with the log notice. And one more to select. Let's select user to capture user level application messages with a log notice. All right, these categories give us a solid foundation for detection and analysis while keeping Sentinel's data clean and efficient. Let's click on Next Destination. We'll add a destination. Destination type is Azure Monitor Logs. This is our subscription, and let's choose our Sentinel Log Analytic Workspace, which is this one. Click on Add Data Source. Click Review and Create. Verify all the settings and finally click on Create. All right, as we can see, has created a data collection rule. Association succeeded. Now your Ubuntu system will start sending useful syslog data into Sentinel, covering authentication, system events, services, and kernel logs. Now let's wait for 5 minutes. Now let's head over to our Azure portal. Go to Microsoft Sentinel, select your log analytic workspace, and click on Logs. Close this window, select the KQL mode, and type heartbeat and click Run. If you see recent heartbeat entries from Ubuntu machine, congratulations, your DCR is successfully collecting data from Ubuntu. If you don't see the heartbeat for your Ubuntu virtual machine in Sentinel, it's most likely because the Azure Monitor Agent cannot authenticate with Azure. The token it was using has expired. To fix this issue, go back to your Ubuntu machine and reconnect your machine and refresh its authentication token. You can do this by running this command on your Ubuntu virtual machine. Make sure enter your resource group, name, subscription ID, location, and tenant ID, and then hit enter. After this completes, wait a few minutes, then check the heartbeat in Sentinel. You should now see your Ubuntu virtual machine reporting correctly. Let's wrap up. This is how you configure data collection rule for an Ubuntu machine. We recapped what a DCR is, walked through how to create one in the Azure portal, linked it to our Ubuntu system, and confirmed data ingestion using a KQL query. With this setup, your Linux system now reliably sends logs to Microsoft Sentinel, giving you full visibility into your environment. Before moving on to Module 4, let's quickly recap what we achieved in Module 3. First, we installed the Azure Monitor Agent on both our Windows and Linux virtual machines. This agent is responsible for collecting telemetry data and sending it to Sentinel. Next, we created and configured a data collection rule which defines what data the agent should collect and where it should be sent. We link both virtual machines to DCR and data collection endpoint, ensuring a continuous and reliable data flow into our log analytics workspace. We validated the connections and verified that logs were successfully ingested using KQL queries, Heartbeat for endpoint availability, and syslog for Linux system logs. This confirms that our environment is ready for real-time monitoring. With both virtual machines onboarded and sending data, our Sentinel environment is now fully prepared to detect threats. In the next module, we will create analytics rules to detect suspicious activity, simulate attacks, and generate incidents. Excellent work. Let's move forward to Module 4, Threat Detection with Analytics Rules. Welcome to Module 4, Threat Detection with Analytics Rules. In this module, our goal is to create and validate detection rules in Microsoft Sentinel for real-world attack scenarios. Now that our endpoints are onboarded and sending logs into Sentinel, we can start turning that raw data into actionable insights. Analytics rules are the detection engine of Sentinel. They continuously scan your log data and generate alerts whenever suspicious activity is identified. We will focus on 4 key attack scenarios. The first one is failed RDP logins. These are brute force attempts on Windows system. Monitoring repeated failed logins helps detect attempt to gain unauthorized access. Second, suspicious PowerShell execution. Attackers often use PowerShell for malicious activity. Detecting unusual or unauthorized script running on endpoints can help stop attacks early. The third one, SSH brute force attacks. Targeting Linux endpoints, repeated failed SSH login attempts are a common intrusion vector. And finally, impossible location logins. This is an identity-based anomaly detection where a user logs in from two geographically distant locations within an impossible time frame. These rules define the logic, the conditions under which an alert is triggered, and the schedule for evaluation. Properly configuring these rules ensures that Sentinel identifies threats accurately without generating unnecessary noise. Once the rules are created, we will generate simulated events on our virtual machines to trigger the detections. For example, we might attempt a failed RDP logins or run PowerShell script that matches our detection criteria. This step allows us to validate the rules in a safe, controlled lab environment. After simulating events, we will verify the incidents are created in the Sentinel workspace. All alerts generated by our analytics tools are automatically grouped into incidents, which provide context and detail for security analysts. You can view these incidents in the incident blade and inspect details like affected systems, users, timestamp, and raw logs. Finally, we will review the detection workflow from our log ingestion to alert generation. You will see how Sentinel turns raw telemetry into meaningful security events and how incidents provide a structured view for analysts to take action. This is a critical step in the SOC workflow, allowing security teams to investigate, respond, and remediate threats effectively. By the end of this module, you will have a set of functional detection rules, a clear understanding of how incidents are created, and confidence in simulating attack scenarios. These rules form the backbone for automated responses in Module 5, where we will integrate playbooks to take action on detected threats. Let's begin by creating our first analytic rule for failed RDP logins, and we will proceed step by step to implement and validate all 4 detection scenarios. Now, before we proceed further, we need to configure Windows auditing so that all important account activities are tracked. This is crucial for security monitoring and for feeding logs into systems like Microsoft Sentinel. Windows has several audit subcategories. The ones we care about are log on, log off, and spatial log on. Now we use the audit pool command to enable auditing, and here is our first PowerShell command to enable our logon logs. And paste it here and click enter. And let's do for the log off, enter, and for the special log on, hit enter. The first command enables logging for all successful and failed login attempts. If someone logs in successfully, it's recorded. If a login fails, it also recorded. This helps us detect unauthorized access attempts. The second command enables logging for log-offs. Tracking log-offs lets us see when sessions end, which helps correlate log-on events with user activity. The third command focuses on accounts with special privileges, such as admins. Success and failures are both logged, which is critical to detect if someone tries to misuse high privilege accounts. Let's check if the auditing is enabled. Enter this PowerShell command and hit enter. Now we can see that log on, log off, and special logons, they all success and failures are enabled. Great. Once auditing is enabled, the security event log on the Windows machine will capture these events. If you're connected to SIEM like Microsoft Sentinel via Azure Monitor Agent or Log Analytics, these logs will start flowing into your workspace, enabling alerting and analysis. Now that our Windows and Linux virtual machines are actively sending logs to Sentinel, we can create schedule analytic rules. These rules continuously scan incoming data and automatically raise alerts when something suspicious happens. Think of them as smart sensors, constantly monitoring your environment and notifying you when thresholds are exceeded. So let's head over to Defender portal by going into security.microsoft.com URL, and on your left side under the Microsoft Sentinel, go to configuration and click on analytics and click on create to schedule query rule. Here, name the rule failed RDP logins. Here you can give the descriptions. That's optional, so I'm going to leave it. And here you can choose the severity, whether it could be informational, low, medium, or high. I'll leave it as medium. And then under the MITRE attack, select tactics, techniques, and sub-techniques relevant to your brute force or initial access. We'll look for brute force. And under the credential access, we choose brute force. And leave the status enabled. Click Next to set rule logic. Next, we have to define our KQL query here. The core logic of our analytic rule comes from a KQL query. Let's take a look at the query we will use. This query looks into our Windows event logs for event 4625, which represents a failed logon attempt. It then groups those failed attempts by account and computer, counts them, and finally filters only those where the failed attempts are greater than 3. Next, we define how often Sentinel should run this query. In our setup, we are running it every 5 minutes, looking back at the last 5 minutes of data. This means every 5 minutes, Sentinel checks, did any account have more than 3 failed logins in the last 5 minutes? If yes, the rule will generate an alert. Now, this is where a lot of people get confused. You will see a field called alert threshold, which defaults to 0. Let's understand why we are keeping it at 0. The KQL already defines when we want the results, only when there are more than 3 failed attempts. So when Sentinel run this query and find any result, even one record, that means a user has crossed that threshold. Therefore, setting the alert threshold is equal to 0 simply means if the query returns at least one row, generate an alert, because our KQL already filters the threshold logic inside the query itself. Now that we have defined our query and alert threshold, the next step is to define how Sentinel should group events into alerts. The setting determines whether we want a single alert summarizing multiple matches or a separate alert for every individual match. Here you will see two main options. The first option is called Group All Events into a single alert. When this selected, Sentinel takes all matching records returned by your query within a single run and combines them into one consolidated alert. This is useful when you want to be notified once per batch of suspicious activity, not for every single event. For example, if 3 users each failed login 5 times in 5 minutes, Sentinel will create one alert summarizing all of them rather than multiple alerts. Use this option for summary detection or threshold-based rules, such as more than 3 failed logins. So I'll select group all events into a single alert because I'm interested in the overall pattern of multiple failed logins, not each failed attempt individually. The second option is triggered an alert for each event. This means every single event that matches your KQL query, we will create its own separate alert. If 3 users each have failed login attempts, Sentinel will generate these distinct alerts, one per user. This option is best for critical or rare events, like a single malware detection or privilege escalation attempt, where each occurrence deserves its own alert. If I were creating a rule for suspicious PowerShell execution or privilege escalation, I would choose trigger an alert for each event because every single occurrence needs immediate attention. Since our current user is failed RDP logins, I will select group all events into single alert. This keeps our incident queue clean, summarizing all failed login attempts into one alert instead of flooding the system with multiple duplicates. And I will leave the remaining settings as default and click Next on Incident Settings. Once we have decided how to generate alerts, the next step is to configure incident settings. Remember, an alert is a signal that something suspicious happened, but an incident is a collection of one or more related alerts that should be investigated together. This section controls whether alerts from this rule will automatically generate incidents, and if so, how Sentinel should group them together. Let's start with the option Create Incident from alert triggered by this analytic rules. When this option is enabled, every alert generated by this rule can create or join an incident in Sentinel. If we disable it, alerts will still appear in the system, but they won't automatically form incidents. That means they will need to be manually reviewed or linked later. For most SOC workflows, it's recommended to enable incident creation so every detection flows automatically into the incident queue for triage. You may also see a note about Microsoft Defender correlation activities. This means that Defender can still link alerts or merge them into existing incidents automatically, even if your analytics rule does not define grouping. Think of it as a teamwork. Even if our rule does not define grouping logic, Defender can still connect the dots between related alerts. Next, we have a setting group related alerts triggered by this analytic rule into incidents. When enabled, Sentinel looks for common attributes among alerts, such as the same user, host, IP address, or account, and groups them into a one single incident. This helps analysts see the full context of an attack chain instead of chasing multiple alerts individually. For example, if a user has multiple failed RDP logins attempts, followed by a successful login, Sentinel will combine those alerts into one incident, showing the complete story. For our alert, I'll keep it disabled and click Next for automated response. Automation rules in Microsoft Sentinel are designed to reduce manual effort by automatically responding when an alert or incident is created. Think of automation rules as your digital assistant, the SOC analyst that never sleeps. So, what are automation rules? Automation rules define what happens automatically when an alert or incident is generated. For example, when our failed RDP logins rule triggers, we might want Sentinel to automatically assign the incident to a specific analyst, or add a tag or comment for quick filtering, or even run as logic app playbook that performs automated actions like disabling a compromised account or sending an email notification. In short, automation rules help your SOC react faster and consistently without requiring human intervention every time. In this section, you will see an option to view all automation rules that may be triggered by this analytic rule. If you don't have any rules yet, it will show no automation rules, but you can click Add New to create a new one. We will not create any automation rule, so I'll go ahead and click on Review plus Create. Here, review all your settings and everything and click Save. And now we have created our first analytics schedule rule. All right, now head over to Windows 10 virtual machine and we deliberately enter wrong pass for more than 3 times. Now enter the correct password. Let's wait for at least 5 minutes and then head over to the Microsoft Defender portal and go to Investigation and Response, and under the Incidents and Alert, click on Incidents. Here we should see our alert. We need to wait a little bit more. And there we go. We received our first failed RDP logins. You can click and explore the details. As you can see, it says failed attempts 5. And on the right hand side panel will give you the computer details. There we go. We have successfully captured our very first failed login attempts in Microsoft Sentinel. As you can see, the query we built is now returning real-time event showing multiple failed login attempts grouped by account and computer. This means Sentinel is now actively detecting potential brute force or unauthorized access activity in our environment. go ahead and click on one of those records, you will be able to see the details, events such as the username, source machines, timestamp, and other contextual information that can help you analyze what happened and when. This is a great example of how raw event logs can be turned into actionable security insights with just a few lines of KQL. So, congratulations, you have just built your first successful detection rule for failed login attempts. In the real SOC, this kind of alert would automatically notify the security team to investigate possible credential attacks. Excellent work, everyone. Let's take a moment to celebrate this milestone before we move on to our next exercise. All right, welcome back, everyone. In this step, we are going to learn how to detect suspicious PowerShell activity using Microsoft Sentinel. PowerShell is one of the most powerful administrative tools in Windows, and unfortunately, it's also one of the attacker's favorites. Hackers use PowerShell for downloading malware, running scripts in memory, or even bypassing antivirus controls. That's why detecting malicious PowerShell activity early is such a crucial part of any SOC monitoring strategy. By the end of this step, you will have a Sentinel analytics rule that automatically detects dangerous PowerShell commands across your endpoints. Before we proceed further, we are going to enable PowerShell script block logging on our Windows endpoint. Script block logging is critical for security monitoring because it records all PowerShell command executed on the system, allowing us to detect suspicious activity like malicious downloads, code injection, or privilege escalation attempts. In a SOC environment, these logs feed into Microsoft Sentinel or Defender for real-time threat detection. By default, script block logging is disabled on Windows. That means PowerShell commands are not fully logged, which attackers can exploit. We will first check if it's enabled, then enable if it's necessary. We'll go to PowerShell and run as an administrator. Click yes. So I'll go ahead and enter my script. If nothing is returned, script block logging is disabled. If enable script blocking log exists and equals 1, it is enabled. In my lab, nothing is returned, which means logging is currently off. Now let's enable it manually via PowerShell. We will create the registry key if it doesn't exist and set the value to 1 to enable logging. So I'll go ahead and enter my script. Let me explain this script a little bit. So the new item creates the key if it's missing, and new item property sets enable script blocking is equal to 1. And using dash force ensures it works even if the key or value exists. And finally, get item property confirms the setting. Once this is set, all executed PowerShell commands will be recorded in event logs. And now we can see enable script block logging is 1, that means it's enabled. Next, we will run a simple command to verify that script block logging is working. I'll clear my screen and enter my PowerShell script here. Let me explain this. Event ID 4104 contains the executed command text. This is what Sentinel or Defender collects for detection rules, like suspicious PowerShell activity. Now that we have enabled script block logging, let's verify that it's actually working. We will do this by running a simple PowerShell command and then checking the Windows Event Viewer to confirm that command was captured. Close this PowerShell window and open a new one as administrator. Click yes. This ensures the updated policy is loaded. Then run the following command. Now open Event Viewer. Navigate to Applications and Service Logs. Go to Microsoft, Windows, and go to PowerShell. Under the PowerShell, click Operational, and we can see we have event ID 4104. Select the event ID and go into Details. Go to the next one, and this is the event that records the script block content. And you should see your script write output hello script block logging inside the event details. Now, when you see event ID 4104, that means your script block logging is now fully functional. From this point onward, any PowerShell command, even complex or malicious ones, will be captured with full context. This is the foundation for advanced analytics in Sentinel because it allows us to detect suspicious commands like invoke web request or download string, and obfuscated PowerShell code, and remote script execution attempts. Once this data starts flowing into your log analytics workspace, you can build detection rules to flag suspicious PowerShell behavior. So, congratulations, you have successfully enabled and verified script block logging. This capability gives you visibility into every PowerShell command run on your systems, a critical layer of defense for any SOC environment. Now that we know how to detect suspicious PowerShell commands using event ID 4104, we need to ensure that these logs are actually collected by Sentinel. By default, only some logs are collected. Today, we will add a custom event log for Microsoft Windows PowerShell or operational to our data collection rule. So navigate to your Azure portal and go to your data collection rules and then select your DCR. Next, we have to click on Data Sources and click on Windows Event Logs. Now, if you remember, we have set all these logs earlier. By default, Sentinel connects to certain Windows logs like security, application, and system, but PowerShell activity is not fully captured in these logs. For example, if someone runs malicious command using IEX, which is information exchange, or downloading string, that activity may never appear in the default logs. Without capturing the PowerShell operational log, we might miss attacks entirely because the in-memory execution does not leave a trace in the usual security logs. So what Microsoft Windows PowerShell operational provides? The Microsoft Windows PowerShell or operational log is specifically designed to track detailed PowerShell activity. It includes script block execution, command executed via IEX or invoke expression, module loads, and remotely executed PowerShell commands. This gives us full visibility into both normal administrative activity and suspicious or malicious behavior. So we have to go into the custom. I have already created a custom event log data connector here. All you need to do is to go into the field here and enter this command and add it. I'm getting an error that event log has already been defined. Microsoft Windows PowerShell or operational. And now these two characters at the end ensures all operational channels under PowerShell are collected. Custom event log allow fine-grained control. We can collect only what's relevant, reducing noise. It enables real-time alerting on suspicious PowerShell activity, such as downloaded scripts or encoded commands. In short, without the custom log, your detection would be blind to some of the most common attack techniques attackers use today. So whenever you plan to monitor PowerShell activity in Sentinel, adding this custom event log is a critical step. It ensures that all script executions, whether benign or malicious, are captured, analyzed, and available for alerting and investigation. You can even filter the log to focus on script block logging or module logging to further improve detection while minimizing noise. So you can specify this custom event log connector here in the field bar and click add and then click save. Let's start by creating our detection rule in our Microsoft Defender portal. Go to Microsoft Sentinel. Under the configuration, click on Analytics. Then click on Create to schedule query rule. Here we have to provide a name. Give your rule a clear name. I will call it Suspicious PowerShell. Good naming helps you find and manage rules easily, especially when your environment grows. And we will leave the severity as medium. And under the MITRE attack, we'll look for PowerShell. Let's choose Command and Scripting Interpreter here and leave the status enabled and click on Set Rule Logic. Now in the rule query box, let's enter our KQL query. Now let me break down this KQL query. So the first one is the event table. This is the main table where all events collected by your data collection rule appear. In our lab, security event is not available, so we use event. The next is where event ID. Event ID 4104 is for PowerShell script block logging, which records the command run in PowerShell. Here is the important thing. It only works if script block logging is enabled via registry or group policy. So this filter events from the PowerShell operation log and ensures we don't pick up unrelated events from other logs. So where event data contains do searches the raw string event data for suspicious command, invoke web request, information exchange, and downloading string are commonly used by attackers to download and execute malicious script. Note, we use contains because in our lab, event data is stored as plain XML string, not structured JSON. And finally, project time generated, computer, event, and event data. This selects only the columns we want to see in the output. Time generated, when the event occurred, computer, which machine executed it, event ID, confirm it's 4104, and event data shows the actual command executed. Under the query scheduling, make sure run query every 5 minutes and look data from the last is also 5 minutes. Next, let's configure the alert behavior. Set the alert threshold to 1. Even a single detection of these commands could indicate a compromise. And then we'll group all events into a single alert. And I'll leave rest of the settings as default. Click next to incident settings. And we will enable our create incident from alerts triggered by this analytic rules. And click next to automated response. And then click on next review and create. Once the validation is passed, click on save to create your analytic rules. Now, as we can see, it is saving our analytic rules. And now the analytics rules is saved. And we have created our suspicious PowerShell analytic rule. Now that we have our PowerShell operational logs being collected in Sentinel and our analytics tools is configured to detect suspicious commands, it's time to test it in a safe, controlled way. We will simulate suspicious PowerShell activity and observe how Sentinel detects it in real time. Remember, this is a simulation using safe commands. Never run actual malware commands on production systems. Now head over to your Windows 10 virtual machine. We will run Windows PowerShell as an administrator. Click yes. Now I'll go ahead and enter my PowerShell command here. Now let's wait for 5 minutes for the schedule analytics rules to run. Now let's head over to our Microsoft Defender portal and under the investigation and response, click on incident and alerts and go to incidents. And as we can see that our suspicious PowerShell alert has been triggered. That's great. Now let's take a closer look at what's inside the alert. I'll click on that. And we can see on the right hand side, we have the incident details like the title, suspicious PowerShell activity. And we can see the severity, what we have set it earlier. It's medium. And it also gave us the status that it is a new alert. When we check the details, you will see the machine name where the command was executed. And if available, you might also see a user account associated with the PowerShell session. Let's check the details inside. Now look at the event data. It contains the PowerShell command that triggers the alert. You will notice it includes keywords like invoke web request, invoke expressions, and download string. These are typical red flags in malicious PowerShell usage. This confirms that our analytic rule correctly identified and alerted on the suspicious PowerShell behavior. Now let's quickly review what happens next in a real-world SOC environment once such an alert is received. Analysts would verify whether the command was legitimate or suspicious. Second, they would pivot into the event timeline, check related users, processes, and network indicators. If it's confirmed malicious, containment steps like isolating the host or disabling a compromised account would be initiated. And at the end, the incident would be documented for follow-up and lesson learned. So even this was just a simulation, this process mimics exactly what happens in a real SOC when PowerShell misuses is detected. Since this was just a test, we will go ahead and close this incident. Go back to incident and click on alert. And on the right hand side, in the top right hand side, click on manage incident. Here you can see the incident name, severity, and incident tags, and who it assigned to. So in real SOC environment, this would be assigned to the SOC analyst. In my case, I will assign it to myself. And under the status, we will click on resolved. And here we give the reason that we tested the custom DCR and suspicious PowerShell analytic rule, and detection confirmed and it's working. We can also set the classification, whether it was a true positive, false positive, or informational expected activity. I'll go ahead and click on confirmed activity under the informational expected activity. And then click on save to close the incident. Closing the incident properly helps maintain a clean and traceable record in Sentinel for audit purposes. In this segment, we are focusing on detecting SSH brute force attacks against Linux servers. The plan is simple and practical. First, we will create a scheduled analytic rule in Microsoft Sentinel that counts failed SSH login attempts per server using a concise KQL query. Then we will deliberately trigger that rule by entering incorrect passwords from a window machine using PuTTY. Finally, we will verify the detection in Sentinel and walk through quick analyst actions. By the end of this segment, you will know how to create the rule, observe the raw Ubuntu auth.log events that the rule counts, reproduced failed logins using PuTTY, and confirm an incident in Sentinel. Let's get started. We will navigate to our Microsoft Defender portal, then select Microsoft Sentinel, and under the configuration, click on Analytics. We will create a scheduled rule that runs regularly and looks for multiple SSH failures within a short window. So click Create and scheduled query rule. We will call it SSH brute force. Let's give the description. Detect more than 5 failed SSHD authentication attempts in 5 minutes. This time, I'll choose the severity as high. And under the MITRE attack, we'll go ahead and look for brute force. And under the credential access, select brute force. And leave the status enabled and click next to set rule logic. And under the rule query, we will provide our KQL query. Let me read through the logic slowly so you can follow and annotate. The first one is the syslog. This is where the Ubuntu's auth.log data is forwarded to Sentinel. And next, where facility is equal to auth, keeps only authentication related to syslog messages. The third line is where process name is equal to SSHD, ensures we are looking at SSH daemon events. This counts failed events for each host in 5-minute time buckets. And finally, this is the threshold. More than 5 failures in that 5 minutes bin triggers our alarm. Next, set the rule schedule. Run every 5 minutes and lookup period of 5 minutes as well. This means the rule evaluates the last minute of data each run for incident grouping. For incident grouping, select to group alerts by computer so multiple failures on one host consolidate into a single incident. And then click next to go to incident settings. I'll leave the default settings here. Click next to automated response. For this lab, select create incident only and do not attach an automation playbook. We want to observe the incident manually, review the settings, and click create. And then click save. Our analytics rules is saving and the analytics rules has been created. We can see our SSH brute force is listed under the analytics rules. Now switch to Ubuntu target virtual machine and Ubuntu SSH authentication events are logged to var/log/auth.log. Run this command. Enter your password. Notice the important pieces: the timestamp, the SSHD process, the failed password text which indicates a failed login, the target username, and the source IP. These are the raw events our syslog feed sends into Sentinel. And the analytic rule we created simply counts how many such events occur per computer in the 5-minute window. Now we will create 6 failed login attempts from Windows machine using PuTTY. Make sure you are using a lab virtual machine. Never perform this against production system. So let's switch to our Windows 10 virtual machine. I'll open the software PuTTY and I'll give a IP address here for our Ubuntu virtual machine. The port 22 is for SSH and we will click on open. Now our username for our Ubuntu machine is lab user. Hit enter. And now we will enter the password couple of times. And now we will enter the wrong password couple of times. While you're doing that, watch the Ubuntu terminal windows running our previous command for the logs. As we can see, we have failed password log line appear for each incorrect attempt. I will narrate as I do it. First failed password, second, third, fourth, fifth, and sixth. Now we need to wait for 5 minutes to trigger the alert. So head over to your Microsoft Defender portal And under the investigation and response, click on incident alerts and click on incidents. As you can see that we have just got an alert. Microsoft Sentinel has raised an incident from the analytic rule SSH brute force Ubuntu. Now go ahead and open the alert. We can see the rule name, alert ID, affected computer, time window and detection time, matches the timestamp we generated with PuTTY. Now click the attached alert and we can see the details, host name, time generated, and failed attempts. This is perfect. Now we'll go ahead and click on manage alert to close the alert. Under the status, we'll go and click on resolved. We can assign it to a SOC analyst, and then we can click on classification, confirmed activity, and put a little note here as a comment. Triggered by PuTTY demo, 6 failed login observed, no further action required for lab. All right, click save, and you have successfully closed the alert. We created an analytic rule that counts failed SSH logins, generated test failures from PuTTY, observed auth.log file live on the Ubuntu server, and validated that Sentinel created an incident with the expected details. Excellent work. You have successfully detected failed SSH logins and confirmed Sentinel alerts in action. Congratulations, you now know how to proactively monitor and respond to SSH brute force attempts on Linux servers. Finally, we are going to configure a rule to detect impossible login locations in Microsoft 365. You might be wondering, what exactly does impossible login location mean? Well, imagine a user logs in from Toronto at 10 a.m. and then 30 minutes later logs in from Berlin. That's physically impossible. Even the fastest airplane cannot make that trip in that time. Such logins often indicate compromised accounts, stolen credentials, or attackers using VPNs or proxy services. Detecting these early is critical for protecting sensitive data and stopping attackers' lateral movement. Let me give you a real world example. A mid sized company saw a spike in sign ins from multiple countries for several employees within an hour. The SOC investigated and discovered a phishing campaign had harvested credentials. Attackers used those stolen credentials from different VPN endpoints across continents. Without monitoring, the attackers could have accessed mailboxes, downloaded data, and created forwarding rules, all before anyone noticed. With an impossible location rule, Sentinel flagged these suspicious travel impossible sign-ins quickly, enabling the SOC to lock accounts and enforce MFA resets within minutes. That containment prevented data loss and a costly breach. Before we detect impossible logins or suspicious sign-in behavior, Sentinel needs to actually receive those sign-in logs from Microsoft Entra ID. That's our identity management service, previously called Azure Active Directory. Think of this connector as the bridge between Sentinel and your Microsoft 365 tenant. Without it, Sentinel cannot analyze user sign-in, audit activities, or authentication attempts, which means no identity-based threat detection. We will enable the Microsoft Entra ID data connector, allowing Sentinel to ingest critical data like sign-in logs and audit logs from our tenant. These Entra ID logs are the foundation of identity monitoring. They include details such as who signed in, from where, using what device, was the sign-in successful or failed, and whether the login looked risky or unusual. Once we have these logs in Sentinel, we can build analytics rules such as impossible login detection, multiple failed logins, or sign in from risky IPs. In short, without this connector, Sentinel is flying blind when it comes to user identity threats. Let's go hands-on now and set it up. Let's go to Microsoft Defender portal, go to Microsoft Sentinel. Under the configuration, click on Data Connectors. In the search bar, type Microsoft Entra ID. We need to click on Get these data connectors button, and here type Microsoft Entra ID. Hit enter. As we can see that our Microsoft Entra ID is not installed. Click on it. And you will see options like sign-in logs, audit logs, and sometimes provisioning logs. Let's click on Microsoft Entra ID. On the right-hand side panel, you will see an option for install. Click on install. As you can see, installing is in progress. And we have successfully installed our Entra ID connector. Let's close this. And if we go back to our previous page, we can see our Microsoft Entra ID is installed. Sentinel will start receiving data usually within 5 to 15 minutes. Now let's go back to our data connector page and click on Microsoft Entra ID. And we can see that the status is disconnected. We need to go and make it connected. Click on Open Connector page. And under the configuration, we need to select Microsoft Entra ID log types. I will go ahead and check all. And then click Apply Changes. And this is successfully applied changes. And if you still see status disconnected, you will see under the sign-in logs there is a prompt. In order to export sign-in data, your organization needs Microsoft Entra ID P1 or P2 license. If you don't have a P1 or P2, start a free trial. So click on this link, and under the free trial, click on Activate to activate your free Microsoft Entra ID trial. Let's build the analytic rule in Microsoft Sentinel. We will use the sign-in logs table and the KQL I recommend for this lab. So go to Microsoft Sentinel. Under the configuration, click on Analytics. And then click on Create and go with Schedule Query Rule. I'll give a name, Impossible Login Microsoft 365. We'll give a description. Detect users logging in from multiple countries within a short time windows, possible compromised account. I'll choose the severity as high. And under the MITRE attack mapping, I will go with the compromised account. Leave the status enabled. Click Next to set rule logic. And under the rule query box, type this KQL. Let's go through with this KQL query. So first is sign-in logs. This table contains Azure Office 365 sign-in telemetry. It's the primary source of detecting user sign-ins and their location metadata. The next is extended country. This is sign-in log store location information inside a nested object. This extracts the country field so we can group by it. Sort by time generated is optional but helpful when you inspect raw results so that newest entry appeared first. Next we have summarize count. It counts sign-ins per user per country in 1 hour buckets. This groups activity so we can spot one user having logins in different countries within the same hour. And finally, where count is flags where a user has more than one country in the same 1 hour bin, our proxy for an impossible location event. Next, set the schedule, run every 5 minutes, and lookup period 1 hour. But running every 5 minutes ensures near real-time detection of new events. For incident grouping, group alerts by user principal name, so multiple alerts for the same user consolidate into one incident. Click next to incident settings, and we will enable create incident from alert triggered by this analytic rule. Click next on automated, and then click review and create, and then click on save. So we have successfully created our impossible login Microsoft 365 analytic rule. All right, now let's simulate an impossible login scenario. I have created a user named Luke Lee. We will make this user sign in from two completely different countries within minutes. First, I will log him in from Canada using his normal network connection. So go to portalazure.com, and as we can see, there is a user. Let's sign in, enter your password, stay sign in, click yes. Now this user is signed in from the Canadian IP address. Now I will sign out. I'll switch to a VPN and let's change the country. All right. Uh, Now we have connected from Netherlands. Okay. Switch back to the page and log him in again. Click yes. Now this user is signed in again from a country Netherlands. This will generate two distinct sign-in events from two countries in a very short time frame, something that is physically impossible for a real user. Once both logins are captured, Microsoft Sentinel will flag this behavior as a potential account compromise. Now let's wait for 5 minutes. And there it is. Microsoft Sentinel has just detected the impossible login incidents. Let's open it up. We can see the previous one. These were just the part of testing. I'll go ahead and open the latest one. The alert shows that Luke Lee with two logins events from Canada and Netherlands, both within the same short time window. You can see the exact timestamps and location captured under the entities and alert tabs. Excellent work. We have successfully simulated an impossible login scenario and verified that Sentinel detected it. This proves how critical it is to monitor for geographically impossible activity. It helps security teams catch stolen credentials before attackers can move further. So when you see an alert like this, treat it seriously. It could mean an active account compromise. Before we move on to Module 5, let's quickly recap what we accomplished in Module 4. First, we created custom analytic rules to detect critical security events, fail RDP logins, suspicious PowerShell execution, SSH brute force attacks, and impossible location logins. Each rule was configured with the proper logic, scheduling, and alert generation to ensure meaningful and accurate detections. Each rule was configured with proper logic, scheduling, and alert generation to ensure meaningful and accurate detections. Next, we simulated attack events in our lab environment to validate that these rules trigger as expected. This is a safe way to test detections before applying them in a production environment. We then confirmed that incidents were created in Sentinel's incident blade, giving us a structured view of alert along with details about affected systems, users, and timestamps. Finally, we reviewed the end-to-end detection workflow, showing how Sentinel converts raw log data into actionable security incidents. This lays the groundwork for the next step, Module 5, where we will implement automation using playbooks to respond to these detections automatically. Great work! With our detection rules in place, we are now ready to explore automated response and streamline our SOC workflow in the next module. Welcome to Module 5, Automation and Playbook. In this final module, we will focus on automating responses to incidents detected in Microsoft Sentinel. So far, we have onboarded endpoints, ingested logs, and created analytics rules to detect suspicious activities. Now it's time to close the loop by automatically responding to alerts. Automation in Sentinel allows our SOC to respond faster, reduce manual workload, and ensure consistent incident handling. We start by opening the automation blade in Sentinel. This is where we manage all our playbooks and automated response workflows. Playbooks are built using logic apps, which provides a visual, no-code interface to define step-by-step actions in response to an alert. We will create our first playbook. For example, we can design a workflow that automatically sends a Microsoft Teams message or email alert whenever a specific analytics rule is triggered. Playbook can also perform more advanced actions such as blocking a user, quarantining a device, or enriching incident data with external threat intelligence. After building the playbook, the next step is to connect it to an analytic rule. This ensures that whenever the rule detects a suspicious activity, such as failed RDP logins or suspicious PowerShell execution, the playbook will automatically execute the defined response. Once connected, we will trigger and test the playbook. For instance, we can simulate a detection event and observe the playbook automatically sending notifications or performing actions. Testing is essential to ensure that automation works as expected and the alerts are handled correctly. Automation in Sentinel streamlines the detect to respond workflow. Instead of relying solely on manual intervention, incidents can now be acted upon automatically, allowing SOC analysts to focus on higher level investigation and threat hunting. Finally, we will discuss real-world use cases such as alerting, automatically notify the SOC team or relevant stakeholders. When implementing playbooks, always follow best practices. Test workflows in a lab environment, ensure proper error handling, and document actions to avoid unintended consequences. Also, monitor automation logs to troubleshoot any failures. By the end of this module, you will understand how to design, connect, and test playbooks and how automation enhances the efficiency and effectiveness of a SOC. With this, we have completed our hands-on Microsoft Sentinel training from environment setup to automated incident response. You now have a full end-to-end understanding of how to deploy, monitor, detect, and respond to threats using Sentinel. Let's explore the automation section in Microsoft Sentinel. First, navigate to Microsoft Defender portal by entering the URL security.microsoft.com and then click on Microsoft Sentinel, and under the configuration, click on automation. Since we haven't created any playbooks yet, the list you see will be empty. That's perfectly fine. This is your starting point for building automated responses. The automation blade is where all playbooks live. Playbooks are workflows into on Azure Logic apps that run automatically whenever a trigger occurs. In other words, they are the engine that turns the alert and incident into an action without manual effort. Here is what you will typically see in the blade once playbooks exist. Trigger type: the event that starts a playbook, like when an incident is created or when an alert is fired. And then status: whether the playbook is active, disabled, or disconnected. And last modified helps track changes for auditing or troubleshooting. Even though the list is empty, this view helps you understand the structure that is triggered to an action actions can be anything from sending an email to the SOC, posting to Teams, blocking a malicious IP, or isolating a compromised device. Think of the automation blade as the central place for SOC response workflows. Once you create your first playbook, it will appear here, and you will be able to manage, monitor, and test it from this page. Finally, remember, even with no playbooks yet, seeing this blade gives you a clear picture of how detection connects to automated response. It's the foundation for faster, consistent, and auditable incident handling. Now we are going to build our first playbook, which will automatically send an email to the SOC when a new incident is created. This is a simple but practical example of automation in Sentinel. So from your Defender workspace, click Automation in the left-hand menu and click Create. Now that we are ready to create a playbook in Microsoft Sentinel, you will notice several options when you click Create. Let's go through each one so you understand when to use them. First, automation rule. This isn't a playbook itself. Instead, it's how you link an existing playbook to an analytics rule or incident. Think of it as the connector that decides when your playbook should run. Next, playbook with incident trigger. This starts automatically whenever a Sentinel incident is created. Use this when your response depends on incidents. For example, sending an email alert, creating a ServiceNow ticket, or isolating a compromised endpoint. Then playbook with alert trigger. This triggers at the alert level before multiple alerts are grouped into an incident. It's useful when you want immediate action for specific alerts like multiple failed logins or suspicious configuration change. There is also playbook with entity trigger, which activates based on specific entity detected in Sentinel, such as user, host, or IP address. You might use this to disable a user or block an IP address automatically. And finally, blank playbooks give you a clean slate. You define the trigger, conditions, and actions from scratch using the Logic Apps Designer. This is ideal if none of the pre-built triggers fit your workflow. For today's demo, sending an email when a new incident is created, we will choose Playbook with Incident Trigger. It's straightforward and demonstrates the power of automation without overcomplicating things. Remember, the key idea is detection happens via analytics rule, and these playbook triggers define how Sentinel responds automatically. Let's click on Playbook with Incident Trigger. Here, choose your subscription and then your resource group. You're working on Sentinel RG Lab. Click. Region would be automatically selected, and we will call it SOC Email Alert. You will notice a checkbox labeled Enable Diagnostic Logs in Log Analytics. Let me explain what this does. When you enable this option, every time the playbook runs, it will send detailed execution logs to Log Analytics. These logs includes when the playbook was triggered and which actions ran successfully or failed, and also input and output of each action, and that is subject to sensitive data handling. This is very useful for troubleshooting. If your playbook does not behave as expected, the log shows exactly what happened. It is useful for auditing. You can verify which indicates triggered automation and confirm compliance. And for optimization, identify slow or failing steps to improve performance. I recommend enabling this option, especially in production environments, so you can monitor and maintain your playbooks effectively. Once checked, the playbook will start sending logs automatically to your log analytics workspace after each run. And then choose your log analytic workspace. Ours is Sentinel -log, and click on Next to Connections. And then click Next to review and create. Verify your information, and then click Create Playbook. Deployment is in progress. And deployment succeeded. As you can see that it says note, grant permissions to the managed identity after deployment. This is when you enable diagnostic logs for your playbook. Azure may prompt you to grant permissions to the playbook's managed identity after deployment. This is because the playbook needs write logs to the linked log analytic workspace. In a trial or test environment, the managed identity might not automatically have the required permissions. After deployment, you will need to go to the Sentinel and go to resource groups, select the resource group and go to access control IAM and assign the log analytics contributor role to the playbook manage identity. So we'll click on add role assignment, log analytic, select, click next, and then click on managed identity, select members, choose your subscription and select your managed identity as logic app, and we can see our playbook here. So select and select, and then click review and assign. And assign. As we can see, the role has been assigned. Without these permissions, diagnostic logs will not be sent, though the playbook will still execute its action. Here is a tip. Always verify the managed identity has the correct permissions for relying on diagnostics. And enter logic apps. Click on logic apps. Click on playbook. And under the development tools, go to logic app designer. Here you will see a canvas. We have our Microsoft Sentinel incident. This set up the playbook to start automatically whenever a relative incident is detected. So let's go ahead and click on add an action. And we will look for alert get incident. Click on that. All right. Let's choose our subscription dynamically. We'll choose our subscription ID, and we'll specify our resource group dynamically as well. Workspace ID is also dynamically we are configuring, and we will choose alert system ID. Let's add another action, add an action, and this time we will choose Outlook and we'll click on send an email. And here we will specify our email to send it to SOC team. We can set a subject, new incident, and we will choose incident title and the email body. There is an alert for your attention. Description. Severity. And importance set to high. And close and click on save. So the workflow has successfully saved. And you should see your new playbook listed with its status as enabled and ready to be linked to analytics rule. Here is a tip in that this workflow is fully visual, no coding required. You can easily add more steps, post to teams, call a REST API, or even isolate a device. This demo demonstrates the power of automation. Once linked to an alert or incident, it runs instantly, reducing response time from minutes to seconds and letting your analyst focus on more complex investigations. Now that our playbook is built and ready, let's connect it to an analytic rule so it runs automatically whenever the rule generates an incident. Remember, analytic rules are the detection engine and playbooks handle the response. This step is where we bridge those two layers. Let's walk through it step by step. On Microsoft Defender portal, under the Microsoft Sentinel, go to Configuration and then click on Analytics. Here you will see all the active rules that generate alerts or incidents. For example, failed RDP logins. Click on a rule to open its detail and then select Automated Response. This is where we can add automation rules to define what happens when that detection fires. Click Add New to add automation rules. Let's call it Email Notification to SOC Team. And under the trigger, make sure when incident is created is selected. We'll go under the action, click on Run Playbook, and we will choose our playbook, SOC Email Alert. And once done, click on Apply and click Next to review and create. Then click on Save. Saving analytics rule, and the analytics rule saved. Now the rule is active. Each time the failed RDP login detection fires and creates an incident, Sentinel will automatically execute the playbook, sending an alert to the SOC team instantly. This integration ensures that your detections don't just create noise, they drive real-time action. It's what turns a static alert into automated response workflow. It's what turns a static alert into automated response workflow. It's what turns a it it's what's done it's what it's what turns a it what turns a static ru- it's what turns a static alert into an automated response workflow, reducing analyst workload and improving response time dramatically. Finally, a quick best practice. Always test your automation in a lab environment before applying it in production. Verify that the playbook permissions are correctly set and that the trigger works as expected. Otherwise, the workflow will not execute. Let's check if Sentinel triggers the playbook when the failed login RDP incident created. We will switch to our Windows 10 virtual machine and we will deliberately enter our wrong password more than 3 times. And now let's wait for 5 minutes. Now let's check the incident. As we can see that our incident alert triggered. Now let's switch to our Outlook and see if our playbook triggered an email. As you can see that we have received an email as we specified new incident. The title is failed RDP logins, and this is what we have specified in our email body. Congratulations everyone, we have successfully built and deployed our first playbook in Microsoft Sentinel. Alright, let's wrap up Module 5, Automation and Playbooks in Microsoft Sentinel. In this module, we explored how automation helps a security operations center work smarter, not harder. We learned how to create playbooks using logic apps, connect them to analytic rules, and test automated responses to incidents. Think of this way, analytic rules detect and playbooks respond. Together, they complete the detect to respond cycle of the SOC workflow. This automation ensures that critical alerts are not missed, repetitive tasks are reduced, and analysts can focus on more advanced threat hunting and investigation. We also discussed real-world SOC use case like automatically sending notifications by email. These automations make the response process faster, more consistent, and scalable. Remember, with great automation comes great responsibility. Always test your playbooks in a controlled environment, use proper access controls, and monitor execution logs to ensure reliability. With this, you have completed the automation layer of Sentinel, the final piece that turns detection into action. You can now have the full picture of how Microsoft Sentinel enables modern SOC operations from data collection to automated response. Great job completing Module 5 and congratulations on reaching the end of this training journey.